Hello friends, welcome to HB Kapadia School. Okay, today we are going to start with 12th standard. Okay, in 12th standard we'll start with 12th physics. Myself is Kunal Pandya and I'm going to start with chapter number 1, that is electric charges and electric field. So before starting with chapter, let us concentrate on the keywords of the title of this chapter, that is electric charges, and over here that is electric field. So it's evident from the title that we are going to study something about electricity. So have you seen this electricity somewhere while flowing? Okay, see, normally electric current passes through the wire, but sometimes also we are able to see the electric current which is not passing from the wire, like this. See, this is a movie scene. MCU fans must have understood which movie is this, but I'm not interested in the movie, but I'm interested in thunder. Okay, see this one, this is thunder. Okay, or we can say lightning. Actually it is electric current which is passing without any wires. Okay, this is thunder. So in this case the electric current is passing without any wires. Okay, and actually the flow of electrons is called electric current, and electron are basically charge. Okay, what are they? These electrons are having some charge. So in this chapter we are going to start something about which is related with charge and the flow of charge. Actually the flow of charge will be there in chapter number 3. We will restrict our study to static charge only. Okay, for the static charge, when the charge is stationary, we can say it is called static charge, and the electricity produced due to that, it is called static electricity. Let me give you an example. What happened in US? There is a hill station in some national park. Let us imagine this is suppose a hill station over here. So what happened, one girl visited that hill station. See, my sketches are like this only. Okay, please bear with my sketches. So one girl like this, let me make some hairs. Okay, yeah. So what happened, that girl visited that national park, and suddenly what happened, her hairs, okay, which were like this, okay, suddenly her hairs went up in the sky. Okay, they were not detached actually, but they just, okay, went up like this in the sky. Let me show you the original photograph. This is the original photograph. You can see these hairs. Okay, these hairs are moving upwards. So what do you think, what is the reason behind her hairs going in upward direction and charge? Okay, so to understand this better, okay, let me show you one experiment. Okay, so this is an experiment. Yeah, in this experiment,
So friends, हमारे पास है
in this experiment we have some beads of paper also, and we have a comb. Comb is made up of plastic. Now when the comb is rubbed with hair, what happens, the plastic gets negative charge and our hair becomes positively charged. Okay, so by rubbing such plastic with our hairs, the plastic gets negative charge. Now let's see what happens in this experiment. Now when the plastic is brought in contact with some beads of paper, the plastic gets negative charge and the beads of paper gets polarized and gets attracted with the plastic comb. Okay, such experiment can also done with the help of some balloons and our hairs. So basically what happened with this girl, see this girl, okay, she used a plastic comb, and after using that plastic comb her hair got positively charged. Okay, okay, see, her hairs are positive charge, and the cloud which was just above her head was a negatively charged cloud. So her hair got attracted with the clouds which were just above her. Okay, so I think you understood what is the attraction, which hair becomes a positive, clouds are always negative. Not necessarily always negative, they may be positive sometimes, but in this case they were negative. Okay, so let's proceed further. These are pure NCERT words. Okay, remember these are pure NCERT words because we have to stick with NCERT. Okay, so what NCERT says about introduction of this chapter: electrostatics, I just talked it about you. Okay, I just talked it. Electrostatic deals with the study of forces, fields and potentials arising from static charge. Okay, arising from static charge. What is static? Static is something which is stationary. Okay, it is stationary. So when the charges are stationary, okay, imagine suppose is a charge, let it be a positive charge. This positive charge creates some forces around it. Okay, imagine suppose is a negative charge. Okay, so this positive charge will attract this negative charge. We can say it is creating some force on this negative charge. Also there is a field around this positive charge. Okay, there is a region around this charge where the effectiveness of this charge is experienced, that is called its field and potential. Okay, potential is similar like gravitational potential. We'll study it in chapter number 2. Okay, so electrostatics, in this chapter we are going to study about electrostatics. So electrostatic deals with the study of forces, fields and potential arising from static charges. Let us proceed further. Now let us see some charging by friction. See, right now when we saw that experiment in which a plastic comb is rubbed with hairs and the plastic comb gets charged. Okay, we also have some similar type of examples, like when the glass rod is rubbed with silk. Okay, again when a glass rod is rubbed with silk, one of these two things, glass or silk, becomes a positive and negative. Okay, let me explain it to you. Imagine suppose this is a glass rod, this is a glass rod, it is rubbed with silk. Okay, imagine suppose this is a piece of silk. When these two are rubbed with each other, what happens? The positive charge remains stationary, but the negative charge shifts from glass rod to silk. Okay, so the electrons pass from glass rod to silk. So imagine these are electrons are passing from glass rod to silk when the glass rod is rubbed with silk. See, we are rubbing this glass rod to silk, so there occurs some frictional force between glass rod and silk, therefore it is called charging by friction. Okay, it is called charging by friction because the glass rod is actually rubbed with silk and some kind of frictional force arises between these two. So when electron pass from glass rod to silk, there will be some deficiency in glass rod. As a result, the glass rod becomes a positively charged. Now the silk is gaining some electrons, therefore silk becomes negative charged. Okay, so what happens when the glass rod is rubbed with silk? The glass rod gets positive charge, remember this thing, and the silk gets negative charge. Okay, let's proceed further. When the plastic rod is rubbed with fur, okay, plastic rod, when it is rubbed with fur, the plastic gets negative charge and fur gets positive charge. How? In this case, the electrons are passing from fur to plastic. Okay, electrons are passing from fur to plastic. As a result, plastic gets negative charge and the fur gets positive charge. Okay, so remember this thing, glass is always positive and plastic, okay, we have to remember this thing, plastic is negative. Okay, so one which loses electron becomes a positive and one which gains electron becomes negative. Let's see, some students might not have understood what is fur, so I have given a picture of fur. See this thing, the girl is wearing something around her head, this thing is called fur. Okay, this is fur. So let's repeat. When the glass rod is rubbed with silk, okay, glass rod gets positive charge, silk gets negative charge. Similarly, when the plastic rod is rubbed with fur, the plastic gets negative charge and fur gets positive charge. Now you must have understood what is fur because I showed a image of that thing. Now let's proceed further. Similarly, see, we just studied about how we are using plastic and fur to make it positive or negative. So same experiment can also be repeated with the pith ball. Okay, we can also use the same experiment with pith ball, but some fundas are different in case of pith ball. So in pith ball, when the pith ball is kept in contact with glass rod, the pith gets the positive charge. Imagine suppose this is a glass rod. Okay, this is a glass rod. glass rod is positive, remember, because it is already rubbed with silk. See, whenever I say that glass rod is kept somewhere in contact with someone, you always supposed to remember in default that glass rod is positive. So when the glass rod is kept near a pith ball, okay, this is suppose a pith ball we have to keep in contact with each other, so automatically the pith ball becomes a positive charge. Okay, you can do this experiment at home also. Okay, so when glass rod is kept in contact with pith ball becomes positive charge. Similarly, if it is kept in contact with this negative rod, okay, tell me what is negative. So negative is plastic, of course, I just told you. So when it is kept in contact with the plastic rod, the pith ball, okay, pith ball when kept in contact with plastic rod, this pith ball becomes negative charge. Okay, now again a question arises, what is a pith ball? Okay, you might not have seen a pith ball, so let me explain it to you. You cannot have a pith ball in a market. You cannot say to a shopkeeper to give you a pith ball, because it's not like it's available everywhere. So let me tell you what is a pith ball, and you can make pith ball at home also. Okay, so these are oranges, I like oranges. Okay, I like oranges very much. See, if we see the layers of oranges, the outermost layer is called a peel. Okay, the innermost portion is called segment. There are segments like this. Okay, you might have seen oranges, and the layer between these two, okay, the layer exactly beneath the peel is called pith. Okay, so what actually is a pith? See, they are not the balls which are made up of oranges. They are not just taking a peel out the oranges and making pith balls with the help of that, but pith actually means something which is very spongy. Okay, pith means spongy. Okay, something which is very spongy is called pith. Okay, so the ball which is very spongy kind of thing, okay, which is made up of very spongy kind of thing, is called pith ball. Okay, see this one, some might have imagined that these are rasgullas, but these are not rasgullas. Okay, these are actually the beads of thermocol. Okay, thermocol which you are using in your various projects. Okay, so these are the beads of thermocols are spongy. Okay, so the beads of these are also spongy. Okay, of course some people have thought that rasgullas are also spongy. You can take rasgullas as a pith ball, but practically I have not done an experiment with the help of rasgullas. Okay, so these are the thermocol beads. Let's revise once again. When the pith ball is kept in contact with glass rod, okay, pith ball when it is kept in contact with glass rod, the pith gets positive charge. Okay, again when the pith ball is kept in contact with plastic rod, the pith gets negative charge. Okay, so let's see what's next. NCERT diagram. Okay, we have to stick with NCERT, it's very important. So with the help of this diagram, okay, NCERT wants to prove that the like charges repel each other and unlike charges attract each other. Okay, let's see how. See, this is a glass rod. The glass rod is suspended with the help of a silk thread. See, you can see this is a silk thread. Okay, with the help of silk thread, a glass rod is suspended. Now when another glass rod is kept in contact with it, okay, this glass rod moves away. Okay, this glass rod which is hung with silk thread, okay, moves away when another glass rod is kept in contact with it. It means that these two are having like charges, therefore they are repelling each other. Same thing happens with plastic rod also. When the two plastic rods are brought near to each other, okay, the plastic rods move away from each other. So in this case also the like charges repel each other. But see, in this case, this is a glass rod. Okay, this is a glass rod. Okay, this is a glass rod. When the glass rod is kept near to plastic rod, in that case these two attract each other. Why they attract each other? Because they are unlike charges. Same experiment can also be done with help of pith balls. In this case, see, there are two negatively charged pith balls. They are having like charges, so as they are having like charges, they are repelling each other. Similarly, these two are positive charges, so therefore they are also repelling each other. But see, in this case, one of the pith ball is negative, another pith ball is positive, so therefore they are attracting each other. So with the help of this diagram, it is evident that when the like charges are kept near to each other, they will repel each other. When the unlike charges are kept near to each other, they will attract each other. Okay, let's see next. Pure NCERT words. Electric charge. Okay, 1.2 you can have NCERT with you, and you can see inside the textbook. You will understand in that way better. So 1.2, electric charge. If a plastic rod is rubbed with fur, see these lines, okay, these lines are directly taken from NCERT. If a plastic rod is rubbed with fur, okay, uh, and when it is kept in contact with pith balls, see, when plastic is rubbed with fur, okay, plastic gets negative charge. Now when this plastic is kept in contact with pith balls, the pith balls will also get negative charge, okay. So when plastic rod is rubbed with fur and it is kept in contact with pith balls, how many pith balls are there? In this case there are 2 pith balls. So these 2 pith balls will get negative charge. So if we imagine 2 pith balls which are negatively charged, which type of force will act between them? Yes, the force will be repulsive force. So we have written that they will repel each other. Once again, this is a plastic rod, okay, this is a plastic rod, okay, it is already rubbed with fur, so it has got negative charge. When it is kept in contact with fur, sorry, with pith ball, the pith ball gets negative charge, okay. Now if also it is kept in contact with another pith ball also gets negative charge. These 2 pith balls will repel each other, okay, these 2 pith balls will repel each other. So what happens when we keep some kind of positive charge, okay, if they are kept in contact with positive charge, what do you think what will happen? Okay, so when these two are, when a glass rod is kept in contact with pith balls, okay, the pith ball will get positive charge, okay, and the glass rod, of course, it will have, it is already having a positive charge, and the glass rod will make pith ball to be positive, okay. Now let's see next. Yeah, see, imagine this is one glass rod, okay, this is a glass rod, it is kept in contact with a pith ball, this pith ball gets positive charge. Now imagine another glass rod, okay, sorry, plastic rod. This plastic rod is negatively charged. When it is kept in contact with pith ball, the pith ball gets negative charge. Now between these 2 pith balls, which kind of force will act? Of course it will be attractive force. Why? Because these 2 are unlike charges. So see these lines are from NCERT. A pith ball touched with the glass rod, see, this is a pith ball, it is kept in contact with the glass rod, okay, attracts, this pith ball attracts another pith ball which is kept in contact with plastic rod, okay. So I hope the concepts are clear, that unlike charges attract each other and like charges repel each other, okay. And you must have imagined these things in your mind. What are pith balls? I have shown the image. So let's proceed further. Again, these are pure NCERT lines. What is polarity of charge? See, I told you that one gets positive, another gets negative. So this property of electricity with which we are differentiating 2 charges is called polarity. So let's see what NCERT says. The property which differentiates the 2 kinds of charges, okay, we are differentiating 2 kinds of charges. Which kind of charges are there? Yes, the charges are, one charge is positive, another charge is negative. So the property which differentiates 2 kinds of charges is called polarity of charge, okay. This is just a simple definition, you have to remember further, okay. Let's see next. See, this diagram is of electroscope. This also is taken from NCERT. When if you have a textbook in your hand, you can have this diagram from textbook also. This is the diagram of simple electroscope. Electroscope is used to know whether the thing is charged or not, okay. So basically this is a very old concept, but still we have to study, because after all we have to clear our basic concepts first, okay. So over here we have this rod, okay, this is made up of metal. See, if we zoom this much diagram, then it is like this, okay. There is a rod, imagine suppose a rod, and there is a hook like this, okay, on which a gold foil, okay, or gold leaf like this is mounted, okay. Imagine suppose a gold leaf, it is mounted on this one, okay, like this, so it becomes like this, okay. So a gold leaf is mounted on such a type of rod. Now when this is made up of metal, okay, this is made up of metal. Now another, imagine suppose is a glass rod. Okay, just we have studied, yes, glass rod is positive when the glass rod is brought near to this metal knob. Okay, the negative charge gets deposited over here. Why? Because metals, okay, have the property in which metals have free electrons. Those free electrons are always attracted towards the positively charged ions. As a result, electron will diffuse, okay, in the upper part. As a result, the lowermost part will get positive charge. The lowermost portion gets positive charge, it will charge this leaf. Okay, leaf initially it is like this. Imagine suppose the front view of the leaf. Okay, it is like this. When it gets charged, okay, as it is getting positively charged, the two parts of the leaf will repel each other, and hence it will become like this. Let me show you. So when it gets charged, it will become like this. Okay, because these two portions are positively charged and they will repel each other. So a repulsive force acts between them, and with the help of this we can say that this glass rod is positive. Okay, so this is a simple electroscope. See, there is another experimental setup also. We can do this thing in metal, sorry, in a bottle also. Okay, in this case, the whole apparatus is inside a glass window so that it doesn't get disturbed due to the atmosphere. So let's see next. This was a pure NCERT diagram. Again, NCERT words about conductors and insulators you might have studied in standard 10th. Let's see what are conductors. Conductors are those which can conduct electricity, okay, like metals. Some substances readily allow passage of electricity through them. Okay, the one which allows electricity to pass through them, they are called conductors. Okay, they are called those which allow electricity to pass through them easily are called conductors. Now let's see what are insulators. Insulators are those which doesn't allow electricity to pass very easily. They are having very high resistance. Okay, so most of the non-metal like glass, porcelain, plastic, nylon, wood offer higher resistance to passage of electricity through them. They are called insulators. Okay, let's see earthing. It is also part of NCERT. These lines are also from NCERT. What is earthing? See, in at your home you might have seen your electric plug, okay, electric pin, which is suppose is an electric plug, okay, in which you can have different type of plugins. It is like this. Okay, the hole which is at the center above the these four holes is called the pin for earth. Okay, and this wire, okay, this is called earthing wire. Earthing wire is connected to this hole. This hole, the wire which comes out from this hole goes straight towards uh, the ground, and actually it is connected with a rod which is further dipped inside some salt. Okay, so actually earthing is done when the excess amount of charge is present anywhere in your electrical appliance. Okay, so if you imagine if you are using a refrigerator, if due to some short circuit the charge gets dissipated to the metal part of the refrigerator. Okay, so when you will touch the metal part you will experience the electric current. Okay, electric shock also you can experience. But if there is a proper earthing in your inside your refrigerator, so in that case the excess amount of charge will get dissipated straight away inside the earth. Okay, so this process is called earthing. You are not supposed to explain these things in your board examination, but it's just for your information. So let's see what NCERT says about earthing. When we bring a charged body in contact with earth, okay, whenever a charged body is kept in contact with earth, all the excess, see I just told you that excess amount of charge gets dissipated inside the atmosphere, so inside the ground. So all the excess charge on the body disappears by causing a momentary current to pass to the ground. See, whenever the charge passes through this wire, okay, imagine there is a positive excess amount of positive charge. When this positive charge passes towards the ground, in that case some momentary current is also produced. Okay, momentary means a current for a very small interval of time through the connecting conductor. See, we have to use a conductor to connect our earth pin to the ground. This process of sharing of charges with earth is called grounding or earthing. Okay, sometimes in some textbooks or in some papers like JW or NEET, you can also see grounding. Okay, so grounding and earthing are one and the same thing. What we have to do, we have to take some you have to dump the excess amount of positive charge from our electrical appliance or any circuit to the ground. Okay, this is called earthing. So let me show you some practical diagram of earthing. See, this is that metal rod just I showed you. Okay, this is a metal rod is kept in contact with some salts. Okay, and this wire goes straight into our plug. Okay, so if this is a plug, okay, in that case this central part, okay, it is especially for allotted for earthing, and our this wire goes straight into this one. Okay, so if there is some extra amount of charge inside our electrical appliance, that will directly go inside the earth. Okay, the circuit symbol of earthing is like this. So whenever you see such type of circuit symbol, okay, in your in any circuit, then it means it is earthing. Okay, this is the circuit symbol of earthing. Okay, see, whenever you see a petrol pump, okay, in petrol pump also, see, this is the tank which fills the petrol pump. Okay, fills the petrol pump means see, petrol pumps are not the source of petrol. Okay, actually they have to get filled up at some interval of time. So this is a petrol tank which fills the petrol pump. So before filling the petrol pump, always they are keeping a key like this, or sorry, a crocodile key or a clamp, so that the excess amount of charge which might be present inside this petrol tank can be grounded. See, also here there is a symbol for earthing. This is the symbol of earthing. So what happens where if there is some extra charge inside this tank truck, so it can create a spark while filling the petrol pump, so that may be a disaster. So in order to avoid this thing, we are always earthing the truck before filling the petrol pump. Okay, let's see next. See, up till now we studied about charging with the help of friction. Okay, now we are going to start charging with the help of induction. Okay, the charging with the help of induction means we are not supposed to rub two things in this case. Okay, without rubbing we are going to charge something. So charging with the help of induction, in that case, imagine suppose this is a metal rod. Okay, this is a metal sphere. Okay, not a rod, I'm sorry, this is a metal sphere. Metal sphere contains electrons. Electrons are free to roam around everywhere inside metal. Why? Because in case of metals only we are having free electrons. Okay, positively charged ions, they cannot move, they just can oscillate about their mean positions. Now there are electrons and there are positively charged ions. Now imagine a glass rod. See, this is a glass rod. Glass rod is positively charged. When the glass rod is kept in contact with this metal sphere, see, this is a glass rod, and glass rod is kept in contact with metal sphere, the electrons will be attracted towards positively charged glass rod. Okay, so the diagram will become like this. Okay, in this case, see, these negatively charged electrons are in the portion where positively charged glass rod is kept, and in this case, see, over here in this region the electron have fled away. As a result, this region has got positive charge. See, this region is not positive as the positive charge are migrating. The positive charge will never migrate. Okay, only electrons are the one which move from one place to other. So in this case the electrons are moving away. As a result, it is this region, the region on the right side, gets positive charge. Okay, so charging by induction, let's go in detail. This is the same diagram. In this case, see, there is a separation of charge. How we are separating the charge? By keeping a positively charged glass rod. Okay, when the positively charged glass rod is kept near to the metal, okay, in that case there will be a partition, there will be a separation of electrons and positively charged ions. The electrons will be accumulated in the region where the positively charged rod is kept. Now in this right hand side portion, if we just dump this portion into the ground, which is process is also called earthing, or we can say grounding. In that case, the excess amount of charge will dissipate in the ground, and as a result this region will get neutral. Okay, this region gets neutral. This region is already negative. When this positively charged glass rod is moved away, in that case these electrons, okay, they are free electrons, they can move anywhere inside the metal, so they will be get redistributed, and this sphere got negative charge. So let's see, initially the charge of this rod, sorry, this sphere was neutral. See, equal number of positively charged ions and negatively charged ions were there. So total charge of this portion was 0, but after some time, after charging, it got negative charge. Okay, so this kind of charging is also called charging with the help of induction, or we can say charging due to induction. Okay, now let's see the NCERT diagram. This diagram is given in NCERT. You can see figure number 5.4. This is figure number 5.4 of our textbook. In this case, we can see there is a method to charge two spheres. Okay, we can charge two spheres, one negative and one positive, with the help of same method. What we can do, see, these initially are neutral. Equal number of negative and positively charged ions are there in these two spheres. When a a glass rod is kept in contact with one of the sphere, see, this is a positively charged glass rod. So in that case, the electrons will be accumulated in this region like this. See, like this. Okay, so in this case, the negatively charged ions will be accumulated in this region, and positive will be accumulated in part B. See, the electrons, see, will move as far as possible, so this B will get positive charge. Now in such conditions, see, these two are in contact with each other right now, but see this diagram, there is a difference. They are not in contact with each other, they are separated. So in that case, again, if this plastic rod also is moved away, in that case the A will get positive charge and B will get, sorry, A will get negative charge and B will get positive charge. So in such a way we can charge sphere A and sphere B. Sphere A negative charge and sphere B gets positive charge. So this is called charging with the help of induction. Now let's see some basic properties of electric charge. So there are basically three properties of electric charge. The first property is additivity of charges. So when it's very simple, see, whenever there are charges like +1, +2, -3, +4 and -5, what will be the total charge? We have to just simply add those charges, keeping that sign in the proper manner. Okay, this is +1, +2, -3, +4, -5. These kind of things kids can also do. So in that case we'll get -1. We'll discuss the unit in later part of this chapter. Okay, so right now you are just supposed to remember that if there are some charges, some are positive and some are negative, in that case we have to follow simple additivity of charges. So this was the property number 1. Let's see property number 2. Okay, the property number 2 is the law of, actually you have studied this thing in chapter number 1 of 11th standard. Okay, that is the law of conservation of charge. So property number 2 is that only. 1.5.2 says that charge is conserved. Charge is conserved means whenever if there is an isolated system, so the total charge of an isolated system remains constant. Okay, so if we can isolate a charge, or if we can isolate a system electrically, in that case the total charge will remain constant. Okay, so see, the total charge of an isolated system, or the total charge of the isolated system, is always conserved. Okay, further, it is not possible to create or destroy net charge carried by an isolated system. Okay, we cannot create charge, we cannot destroy the net charge of an isolated system. Yes, we can destroy or create the particles which are having charge. Okay, the charge carrying particles can be created and destroyed, but we cannot create or destroy any charge. Okay, so we can create or destroy the charge carrying particles but not charge itself. Okay, now let's see the property number 3, that is quantization of charge. Quantization of charge says that the fact that the electric charge is always an integral multiple of E is called quantization of charge. See, whenever there is a charge, that charge is always in multiples of some kind of a specific charge which is called E. Okay, this value of E, you have to remember always the value of E is always 1.6 into 10 is to minus 19 coulomb. Actually it is the magnitude of magnitude of charge of electron. Let's see further quantization of charge. Experimentally, it is established that all the free charges, okay, whenever there is a free charge, it is always in integral multiples of some basic unit of charge is denoted as E. What is E? Remember this thing, E is 1.6 into 10 is to minus 19 coulomb. See, while writing this theory, okay, you have to write the exact value of E. This is 1.602192 into 10 is to minus 19 coulomb. But even if you are writing this thing, then also it's okay. And in all the numericals, you have to take this value. E is equal to 1.6 into 10 is to minus 19 coulomb. But while writing the theory portion of quantization of charge, it is always preferable to write this value. Okay, so this was the theory of quantization of charge. So let me explain this thing in detail, because quantization of charge is not a thing which can be understood very easily. Okay, so quantization of charge, see, let's see what is the meaning of term quanta. Okay, for that I have an example. Yes, this is a dairy milk chocolate. I like this chocolate, so I have taken this diagram. So imagine a shop. Okay, this is suppose a shop which distributes, suppose a shop, okay, it distributes, okay, only a dairy milk chocolate of 10 rupees. Okay, it is not having a chocolate of dairy milk of 5 rupees or 15 rupees and fruits and nuts and roasted almonds, and those kind of chocolates are not available in shop. Just 10 rupee dairy milk chocolate is available. Okay, let's imagine. Okay, so this is a shop which have dairy milk chocolate, which sells dairy milk chocolate of just 10 rupees. Now if a person has a 10 rupees, can buy one chocolate? Yeah, it can have one chocolate. If he has 15 rupees, then how many chocolates he can have? Yes, he can have just one chocolate plus 5 rupees will be with him. Okay, he cannot buy an extra amount of 5 rupees. Okay, imagine a guy is going somewhere in a shop and telling that I have 15 rupees, give me one dairy milk chocolate of 10 rupees and give me some pieces of dairy milk chocolate like this. Okay, this is not possible. Okay, this thing is not possible. No shopkeeper sells chocolates in pieces. Okay, it always comes in fixed packet. Okay, this is a packet of a chocolate of 10 rupees. This packet kind of thing, this packet, okay, please concentrate, this packet is called quanta. Okay, sorry, quanta packet is called, wait for some time. Okay, this packet is called quanta, and this is the starting of quantum mechanics. Okay, so this is a quanta. So packet is quanta. So it means whenever there is a charge, okay, let's again see the quantization of charge. So quantization of charge says that whenever there is a free charge, that charge may be E, it may be 2E, it may be 3E, and so on. It can never be E by 2 or 3E by 2. Such kind of things are not possible. It cannot be 1.5E, 1.6E. These kinds of charges are never possible. This thing is called quantization of charge. Okay, always a charge comes in fixed quanta. It may be E, it may be 2E, it may be 3E, and so on. So let's see quantization of charge once again. Yes, Q is equal to NE. What is N? N can be 0, 1, 2, 3, and so on. It can never be 1.5, 2.5, or 3.5 or something like that. Yes, remember the value. E is equal to 1.602192 into 10 is to minus 19 coulomb. In examination, you have to write E is equal to, sorry, in examination for numericals, you have to write 1.6 into 10 is to minus 19 coulomb. Okay. So this was first 3 theories of our textbook. In next lecture, we are going to study about Coulomb's law. Okay. So before leaving, let's do some homework. Okay, see, you have to remember this table. Okay, write this table 3 times. Okay, you have to write this table 3 times. Actually, it is the information, it is the data about mass and charge of some basic particles like electron, proton, positron, alpha particle, neutron, deuteron, and gamma. Okay, so gamma is a ray, it will not have any charge and mass. Okay, so you have to remember this table, remember all the values. Okay, I will be asking you in the live lecture whenever it's possible. So this was it. You have also in homework, this worksheet is also for homework. You will be having your worksheet via any social media or anything. We will be delivering it to you. So in worksheet you have to do type A. Okay, finish the homework, otherwise you will be, your face will be like this in your examination. Okay, so please do the homework, or otherwise remember this face. Okay, that's all. So this video was by Kunal and Pandya, also in collaboration with HB Kapadia School. Thank you very much.